On power-assisted rack and pinion steering systems, inside the steering rack is a sealed hydraulic piston. To provide assist, pressurized fluid is pumped into the rack through ports on either side of the piston. The fluid pushes the piston and the rack in the direction of the turn. Let's look at how the power steering system controls the flow of pressurized fluid.
The system uses a valve assembly to direct hydraulic fluid from the pump to one side or the other of the rack piston. This valve is called the spool valve. As the steering wheel is turned, a component inside the spool valve called the torsion bar begins to twist. The torsion bar is attached to the pinion at one end and the spool shaft on the other. The twisting of the bar causes a valve body inside the valve housing to rotate. Now the valve body allows pressurized fluid to travel through the valve on the side of the higher pressure and into the rack housing. Here it provides an assist directly to the piston. As the steering wheel returns to its normal position, the torsion bar straightens. Pressure now becomes equal on both sides of the piston, and the power assist is eliminated.
Several types of hydraulic pumps are in use, but one of the most common is the vane type. A vane pump is driven by an engine belt, which powers an internal rotor. The rotor has a number of slots fitted with thin metal plates. These are the vanes. The vanes are free to move up and down within the slots of the rotor. The rotor and vane assembly rotates within an oval-shaped chamber called the ring. Centrifugal force keeps the vanes and ring in contact with one another. The force also seals the vanes as they slide inside the surface of the ring. In the housing of the pump, alongside the rotor, are two ports. The output port sends pressurized fluid to the spool valve, and the input port receives return fluid. Let's take a closer look at the movement of fluid through the pump.
As the rotor turns, fluid is picked up on the sides of the ring where the chamber is narrow with respect to the intake ports. The turning of the rotor also increases the size of the cavity between the vanes. The cavity fills with fluid. As the cavity reaches the widest part of the oval, it passes the intake port. Now the fluid is trapped inside. The continued movement of the fluid-filled cavity through the oval reduces the size of the cavity. As the cavity shrinks, the pressure of the fluid increases. Finally, the pressurized fluid reaches the pressure port where it exits the ring and moves to the spool valve. The system works by converting rotary motion into fluid pressure.